We have a question, once again, it's involving a right angle triangle because you're assuming a horizontal ground, completely vertical wall, okay? And what it wants us to do is wants us to find the height of the wall H. Now we're going to be using either Pythagoras' theorem or Sohcahtoa. When you're using Pythagoras' theorem, you need to know two sides out of the tree to find the other side. This is not like this in this question, so we're going to use Sohcahtoa, which is silly old Harry chased a horse through our attic. Sohcahtoa. Now, what we're going to do is we're going to figure out which ones are we using, okay? Well, facing the 22 degrees is the opposite. So the opposite is actually the height of the wall, and the 12 meters here is the adjacent, and the hypotenuse would be the one side we actually don't have. So we're going to choose Toa, tan. Tan, what angle are we talking about? Tan 22. Equals opposite over adjacent. Opposite is going to be the H, which is the height of the wall. And then adjacent will be 12. Okay. Then we cross multiply the 12 as division on the right, which means it can be multiplication on the left. And then we enter 12 tan 22 into our calculator and hopefully find out what is the angle. Okay, so 12 tan 22. And we get 4.848 or 4.85. Sorry, H equals 4.84, what was it again? 8483. But it says corrected two decimal places, so it's going to be H equals 4.85. Which makes a lot of sense. Okay, now let's move on to question 2. When the angle of elevation of the sun is 15 degrees, an upright flagpole casts a shadow of length 18 meters. Calculate the height of the pole correct to one decimal place. Well, once again, we want the height of the pole. We're told that this angle is 15 degrees. You should probably pause now and give this a go yourself. So once again, we're going to use silly old Harry chase the horse through our attic. Okay, the hypotenuse would be the yellow line. We're not after that. The opposite is the blue line because it's looking directly at the angle. And finally, the adjacent is the green side. Okay, so what we have is we're looking for the blue side, which is the opposite, and we know the adjacent. So once again, we're going to use tan. Tan, what angle are we talking about? 15 degrees equals the height of your flagpole, which is the opposite, divided by your adjacent. Once again, multiply the 18 as division on the right becomes multiplication on the left. So it's going to be 8 tan 15 equals H. Put it into the calculator, 8 tan 15. And what we get there is 2.14. So our height to one decimal place is going to be 2.1. The height of that flagpole is 2.1 meters. Okay, now we're on to question 3. The distance P of the top of the wall from Q on level ground is 24 meters. The angle of elevation from point P from a point Q is 29 degrees. Calculate the height H of the wall correct to two decimal places. Okay, so calculate the height H to two decimal places. This time we actually know the hypotenuse, and the height of the wall is the opposite because it looks at the 29. So once again we go for a rhyme, silly old Harry chased a horse through our attic. This time I want to use opposite. I want to know the opposite, but I need to use the hypotenuse because it's the only one I have. So that means we're going to be using sine. Sine 29 degrees equals opposite, which is H, because it's the height of the wall. The hypotenuse is 24. Cross multiply 24 is division on the right, which makes a multiplication on the left when I move it over. And then what we have here is 24 sine 29, which is 11.635. Correct to two decimal places. I think we're looking at 11.64 because 35 is closer to, let's show you what I mean there. So I know some of you don't like the rounding off too much. So what we have here is, see the way the 35 here, 35 is closer to 40. That's why it makes it 64. Okay, so H equals 11.64. Okay, great. Now we're on to question 4. 1, 2, 3, 4. Find the vertical height that the ladder reaches on the wall. We're looking for h. Now this time we don't know the angle, but we know two sides already. This is an indicator we're going to be using Pythagoras' theorem, where the longest side squared equals the smaller side squared and added together. So we got 3.7 squared, and we got h squared and 1.2 squared. Then we obviously got to use the calculator here to get 3.7 squared equals 13.69. We have h squared here, and then we got to use 1.2 squared, which is 1.44. Then we're going to do 13.69 take away 1.44, because the 1.44 is addition on the right, which means when it travels to the left hand side of the equals, it becomes a negative. So it's 13.69 take away 1.44. And long and behold, what we get here is 12.25. And 12.25 square root that, and you get 3.5. So your height is 3.5. Okay, next thing we need to do is we need to get the angle. Okay, so this is an angle question, and the only way angle questions finish is whether you use sine inverse, cos inverse, or tan inverse, and which ones you have to choose from. Well, as it turns out, because I know all three sides, I can use any of them I want. This is the hypotenuse, this is the opposite, and this is the adjacent. Okay, so what I could use is I could say sine inverse, opposite over hypotenuse. Remember, silly old Harry. So I could use 3.5 over 3.7. That would get me the correct answer for the angle. I could also use cos inverse, which would be your 1.2 divided by your 3.7. Remember, adjacent over hypotenuse if you're using cos. Now, the only reason I'm using sine inverse and cos inverse is because it's an angle question and I'm being asked to get the angle. I could also use tan inverse 3.5 over 1.2. Okay, I'm expecting an angle bigger than 45 degrees because we can see the wall is a lot higher than the ladder rests away from it. So the opposite is much larger than the adjacent. Pick any one of them I want, and we should always get the same answer. So 3.5 divided by 3.7. There you go, 71 degrees. If I was to do tan inverse instead, my 3.5 over my 1.2, you only need to do one of them, don't need to do all three. Once again, 71 degrees. It didn't matter which one I chose, okay? All right, you guys, all right, all good. Now, question 5 is an awkward looking question, but don't let the 3D diagram fool you. It's very much a rectangle. Okay, so sometimes 3D diagrams, they cause more hassle than they're worth. So this is my rough diagram of what I believe they're doing. It's meant to be equally spaced, and then here's my diagonal, like so. Okay, this is 30 degrees, and if the height is 1.6, calculate the diagonal length of the diagonal bar. The length of the diagonal bar is obviously the hypotenuse, which is represented by green here. Okay, so I'm looking for the hypotenuse, and I'm going to have to use the opposite because on the other side I know is the opposite. I'm looking for the hypotenuse and I know the opposite. So that's silly old Harry. That's opposite and hypotenuse. Chase a horse through our attic. Okay. So what we're going to do here, guys, is we're going to use tan 30. Or sorry, we're going to use sine, opposite and hypotenuse. So sine 30 equals the opposite, which is 1.6 divided by the hypotenuse, which we'll just call x. Now, this one's a difficult question because x is in division. So if x is division on the right, it will be multiplication on the left. Okay, the x is being multiplied by the sine 30. However, if the sine 30 is multiplication on the right, that would make it, or sorry, if it's multiplication on the left, it would make it division on the right. Please remember, hypotenuse always has to be bigger than an opposite. So you have to get a bigger answer. If you don't get a bigger answer, you've gone wrong. So divided by sine 30. Put that into your calculator, lads, and you get an answer of 3.2 meters. So the length of the diagonal fence is 3.2 meters. Okay, so that's questions 1 to 5, and this is question 10. Now, don't let question 10 fool you either. If you were in a helicopter and you were flying directly above the center of this diagram, the diagram would look something like this from directly above, right? It looked like a square plot, okay? You'd have your tree in the corner, would be like this. That'd be B, that'd be C, that'd be 24, and that would be 45. And once again, you can find the diagonal of B to C by using Pythagoras' theorem. We'll just call it X. So X squared equals 45 squared plus 24 squared. Once again, just go to the calculator. And you get 2,601. Square root that to get your answer. You get an answer of 51. Okay, happy enough with that? 51 meters. The angle of elevation from the top of the tree is 21 degrees. Find the height of the tree correct to the nearest meter. Well, what this is doing here is we're actually concentrating on this diagram here, where this is distance, the green line is distance along ground, the yellow line is what angle it makes to the ground, and then this makes a right angle triangle with the pink line, which represents the height of the tree. So if I was to do that diagram in 2D, which is probably the best way to explain these things, I always find I break up my 3D diagrams into 2D a lot. So I'm just going to do my tree here. Okay, and here we go. This one here is my tree, just in green. Okay, that makes this point here B, this point here C. We know that it's 51 meters apart. We know that this diagram is 21 degrees. And then we're looking for the height of the tree, which will be the opposite side, which we'll just call H for argument's sake. Now, I'm going to use, I want the opposite, but I know the adjacent. So I'm going to use Toa. So I'm going to use tan 21 degrees equals your height above 51. 51 is division on the right, which makes a multiplication on the left. So it's 51 tan 21. Sorry guys, I'll rewrite that. Give myself a bit more room over here as well. So it's going to be 51 because it's multiplication on the right, which makes, sorry, division on the right, which makes a multiplication on the left. That equals your H. Now you get your 51 tan 21. And you get 19.57. I want it to the nearest meter, so it'll be 20 meters. Okay, happy days, guys. All right, that's it. 1, 2, 3, 4, 5, and